Since chlorine is a negative ion, it's called an anion. Now, sodium is a positive ion, so this is cation. We put the positive sign here. This is a cation. Okay, keep that in mind. Now, when these two guys combine, this is how you write formulas for ionic compounds. This is going to be an ionic compound. You put the metal first, and then you put the non-metal. If you had to use more than one sodium for this combination, you put it here. You say Na2 or Na3 or whatever number of sodium atoms you use. In this case, we just use one to satisfy the chlorine and one chlorine to satisfy the sodium. So we use 1 and 1. The ratio is 1 to 1. In chemical formulas, you don't have to write the 1 at all. That's why here we just have the sign. Here we just have the sign. We don't need to state that this is only one molecule of this. We don't have to put a 1 to say that we use only one sodium atom. We don't have to put a 1 to say that we use only one chlorine atom. So this is the compound, and this compound has a name, and this is how you name it. You name the metals first, exactly as it sounds, sodium, and then the non-metal, you name it, but you change the ending by IDE. So the name for this compound is sodium chloride, right? This is how you form ionic compounds, forming and naming ionic compounds. This is what we're going to be seeing now. Forming and naming ionic compounds. Okay, if you need to screenshot, take pictures, ask questions, you can always do it. Remember, I'm going to upload this video on Google Classroom, the link, so that you can watch it anytime you need to see it, for you to do the homeworks, for example. Okay, I'm going to do a next example. This is very important to me because it explains to you, I'm going to explain to you how, let me just put it here, sodium chloride. How to deal with elements that require more than one electron to be stable. If I ask you, for example, to do the combination or to combine, the same thing, magnesium and not chlorine, fluorine this time. Let me ask you, how many valence electrons magnesium has and how many valence electrons fluorine has? Can anybody tell me? Anyone? How many magnesium has?
2.
Thank you. Mg, first letter is capitalized, second letter is lowercase. So we have magnesium and fluorine here. And magnesium, you told me, has 2 electrons. 2 electrons, 2 valence electrons. So I'm going to put one here and the next one here. Okay. About fluorine, how many valence electrons fluorine has?
7.
7.
7, thank you. So we have 1, 2, 3, 4, 5, 6, and 7. Okay, so let me ask you a question. Which one is going to be donating electrons here, and which one is going to be accepting the electrons here?
Magnesium is donating and fluorine is accepting.
That is correct. Remember that. Metals will always be donating, while non-metals will be accepting electrons. So magnesium is going to be donating electrons, and fluorine is going to be accepting them. Okay, therefore, if fluorine is going to be accepting electrons and magnesium is going to be donating these electrons, at the end of the process, which one is going to be positive and which one is going to be negative? Which one is going to be positive? Which one is going to be negative at the end of the process? Right now, they are neutral because they haven't given or donated any electrons yet, but that's going to happen. Which one is going to be positive after the donation and which one is going to be negative after the donation?
Magnesium is going to be positive and fluorine is going to be negative.
That is correct. The one that accepts the electrons is negative. The one that gives the electrons is positive. Therefore, what type of ion is fluorine going to be and what type of ion is this guy going to be? Remember, you have two, you have cation and an ion. Fluorine is going to be, let me put the negative because you just told me it's going to be negative. This is going to be positive, right? And later we're going to see the charge that they have. Which one is going to be an ion? Which one is going to be cation?
Magnesium is going to be cation and fluorine is going to be an ion.
That is correct. So we're going to have an ionic bond here. So this is going to donate electrons, magnesium, and fluorine is going to accept electrons. So electrons are going to move in this direction. Now, how many valence electrons fluorine has naturally? 7. And magnesium has 2. So if magnesium donates, magnesium has to donate the 2 of them. But fluorine cannot accept the 2 of them because it wants to have 8, not 9. It has 7 right now. If 2 more electrons come, then fluorine is going to have 9, but it wants to have only 8. So what is going to happen here? Pay attention because I'm going to tell you. Magnesium is going to donate 1 electron to this fluorine atom. And then we're going to have a next fluorine atom down here. And magnesium is going to donate the next electron to this fluorine atom. You understood? Did you understand that? I will repeat that. Magnesium cannot combine with only 1 fluorine atom because 1 fluorine atom is not going to be enough for magnesium to donate its electrons. So magnesium needs to combine with 2 fluorine atoms so that it can give 1 to this fluorine atom and 1 to the next fluorine atom. This has to be a win-to-win relationship. Magnesium needs to be stable after this process and fluorine. So fluorine, this one, will take 1 of the electrons and this one is going to take the other electron. Remember, I just didn't draw the 7 valence electrons that fluorine has, but you know it has it, okay? So now this fluorine is going to have 8 after it receives this, and this one is going to have 8 also after it receives this. And magnesium is going to be left without without the outermost energy level. Magnesium would be like this. Let me just put it again in case you want to see what is going to happen to magnesium. Magnesium has 12 electrons in total. This is the first energy level. This is the second one. And this is the third one. In the first energy level, magnesium has 2 electrons. Let me just draw that for you to see. You have 2 here, 1 and 2. You will have 8 here, 1, 2, 3, 4, 5, blah, 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 8. And it has 2 in the outermost energy level. This is the valence electrons, 2, okay? Now that magnesium has given these 2 electrons, these electrons disappear. And this is just an empty space. This is no longer an energy level. So this becomes the last energy level where it has 8. I just didn't draw the 8 electrons, but in the second energy level, magnesium has 8. If you don't believe me, you can just go ahead and check your electron configuration. You have it. That's why I asked you to have it. But if you still don't believe in yourself, you can just double check this. D6 and then 3s2. That's magnesium, 12 electrons, 2 in the first energy level. Oops, I forgot the 2 here. 8 in the second energy level and 2 in the last energy level. These 2 electrons were donated to fluorine atoms, and then this just disappeared. This now becomes the last energy level where it has 8 electrons. Okay, so whenever you find a situation like this, that one element, one atom is not enough to satisfy the other, you just need to bring more of the same one that is not enough. So since fluorine is not enough to satisfy the magnesium, I need to add another fluorine to help magnesium to achieve the octet rule, the 8 electrons, to have magnesium donating the 2 of its electrons. Is there any questions here before I move ahead? Questions are allowed and welcome. Is there any questions before I move ahead? Okay, that means no.
Actually, one.
Okay, what is your question?
When you're naming the compound, how did we get the chloride at the end? I've actually never got that.
Okay, yes. Actually, let me name this just now so that you can have it. Remember, you have to, in the formula, you put the metal first and then the non-metal. So this is going to be your formula. How many magnesiums you had to use? Only one. One magnesium was enough to satisfy not only one fluorine, but 2 of them. So since I use 2 fluorines, this formula is going to have a 2 down here. This is going to be MgF2 because we had to use 2 fluorine atoms. Okay, and I'm going to answer your question now. Just give me 1 minute. We know that this is the anion. I'm gonna label it later. But what is the charge that fluorine has? How many electrons every fluorine atom receive? And notice that I'm saying every, I'm saying each, I'm saying per fluorine atom. How many electrons were received? 1. So we just have to put 1 here, 1 negative. But how many electrons magnesium donated?
2.
2. So instead of having just a plus sign here by magnesium, we're going to have a plus 2. Okay. Now the charge of magnesium is plus 2. And I explained that before. I'm going to repeat it now because I don't want you to be lost later. Let me first of all separate this from here. Oops. Okay. They're supposed to be together, but I just want to have everything. Okay, that is better. 2 fluorines with a negative charge, 1 magnesium with a plus 2 charge. And again, magnesium had 12 protons and 12 electrons. Since it lost 2 electrons, it lost 2 negative charges. Now it's going to have 2 extra positive charges. It's going to be unbalanced to the positive side by 2. And that's why we have plus 2. Fluorine had 9 protons and 9 electrons, but since it received 1 electron, now it's going to have 1 more electron than the protons it has. It's unbalanced to the negative side by 1. How many fluorines we had to use? 2. That number belongs down here. Up here belongs the charge. Down here belongs the number of every atom that you use. How many magnesiums we use? 1. So we don't put anything. How many fluorines we use? 2. Therefore, we put a 2 here. What is the charge for magnesium? Plus 2. Why? Because it donated 2 negative charges. What is the charge for fluorine? Negative 1. Because it received 1 negative charge each. All right. The name, I was forgetting about that. The name for this now is going to be Magnesium, you always name the metal first. Please write that down. Name the metal first, and then you name the non-metal, but the ending changes to IDE. So the name for this is magnesium fluoride. Okay, and that's the formula, MgF2. Now, this is sodium chloride. This is table salt. This is the one that you eat every single day. Sodium chloride. Even though it's made up of sodium and chlorine, it's not sodium chlorine, but sodium chloride. That's how you name the anions or the negative ions. Chloride is derived from the chlorine, but it's not chlorine anymore, because chlorine is the one that has the same number of protons and electrons. It's the one that is an atom. Remember, atoms have the same number of protons and electrons. Atoms are neutral. Atoms are not combined with anything. Ions are combined with something. They have received or lost electrons. The cations are named exactly as the element, sodium, magnesium, but the anion has a different name. It changes the ending by IDE. So instead of being chlorine, it's going to be chloride. Okay? Any questions? Because at this moment, I'm going to give you something for you to do. One exercise like this, just like this. Is there any questions before I move ahead?
No.
No.
Okay, so you're ready to do one more, one by yourself. Okay, there we go. So I'm gonna ask you to combine these two elements, sulfur and potassium. There you go. Please do the combination of these two guys. Take into account which one is going to be given, which one is going to be receiving. I need you to label. Let me just explain here everything I want. Combine and state and label the cation, anion, charge. Okay, this is what I want you to do for me now. If you're able to do this, then I can say that you understood what I said today, what I explained today. Hint, start with the Lewis structure. That's my hint to you. Oh, I have a question. Open the chat and tell me if you can see the option to attach a file here on Zoom. Can you attach a file there?
Yeah, we should be able to.
Okay, if so, attach your work here on a chat. Is anybody stuck? Okay, I'm gonna pause the recording because it doesn't make sense for the meeting to be recorded while you are working.